purification of organic compounds. Next method is fractional distillation. This method is used to separate two or more miscible liquids contained in the mixture which are having boiling points close to each other. So, mixture contains two or more miscible liquids, okay, miscible liquids which are having boiling points close to each other, okay. Also, it contains a fractionating column, Before entering into the condenser, this condensing liquid, this mixture is passed through this fractionating column, and this fractionating column is a long tube, which is fitted at the mouth of the round bottom flask, okay, and the mixture is taken in the down bottom flask. On heating, what will happen? The more volatile component, on heating, more volatile component will vaporizes, more volatile component, or which is the component having the low boiling point, okay. So, on heating, what will happen? This changes into vapors. This volatile component vaporizes and the fractional column is filled with this volatile component, okay, and this volatile component will reaches at the top, okay. Next, less volatile component or those component is having high boiling point will vaporizes and it will hit on the fractionating column and condenses and flows down, okay. They condenses and flows down. So, liquids will flows down and the vapors will move up. As a result of this, the vapors at the top of the fractionating column will be enriched with those component which is having low boiling point or more volatile component, okay. Then these vapors reaching at the top, then after that they will pass through the condenser, they will condenses and collected in the receiver, okay. So, as a result of this vaporization and condensation, what will happen? The first we will separate different components in the mixture which are having almost similar boiling points, okay, and the remaining liquid present in the flask is enriched with those compounds having high boiling point, okay, those compounds having high boiling point. Like this we can separate this component, okay. As a series of successive vaporization and condensation is taking place in the fractionating column and different components can be separated, okay. And also this fractionating column contains different plates. In some cases there will be hundreds of plates. If the fractionating column is used commercially, there will be hundreds of plates are present. These plates are called as theoretical plates, okay, where the condensation and vaporization is taking place, okay. Now let us discuss about the apparatus. Apparatus consists of round bottomed flask in which we are taking the mixture, round bottom flask, and at the mouth of this round bottom flask there is a fractionating column where the separation of the components are taking place, that is vaporization and condensation is taking place, vapors will move up and condensed liquid will flows down, okay. Next is condenser. the vapors will move towards the condenser. There it gets condensers and the liquids will be collected in the receiver. Okay, fourth part is receiver. These are the different parts of this apparatus in the fractional distillation. Okay, now what are the different applications of this fractional distillation? Applications. Different applications are, first one, this is used in the purification of water. Purification of water. Next, it is used for the distillation of air. Distillation of air. We know air contains different gases. Okay, so different gases present in the air can be separated using this method. Okay, gases present in the air can be separated. Now, it is used to separate crude oil. For the distillation of crude oil, okay, in the petroleum industry, to separate different fractions. Okay, this crude oil can be separated into different fractions like kerosene, petrol, diesel, etc. Okay. Next application is, it is used in oil refineries and chemical plants to separate different organic compounds. Okay. Now, one more application is there. It is used to separate different mixtures like alcohol water mixture, then acetone, methanol mixture, etc. can be separated by this method. Okay. Purification of organic compounds. Next method is distillation under reduced pressure. This method is also called as vacuum distillation. Okay. This is used to separate liquids having high boiling points. Okay. Used to separate liquids having high boiling points. Okay. Now, before reaching these boiling points, certain liquids will decompose. So, it is difficult to distill such compounds. So, we have to use this method. Okay. So, purifying these compounds, we have to reduce the pressure. Okay. So, in the vacuum distillation, when we reduce the pressure, what will happen is their boiling point, the boiling point of the liquid also decreases. Okay. As a result of this, before decomposition, they will boil and distillation can be done easier. Okay. Now, in this case also, the pressure is reduced in the help of a vacuum pump. Okay. Distillation is taken place in the presence of a vacuum pump. Okay. Let us take one example. In the case of glycerol. Okay. Glycerol is having a boiling point 563 Kelvin. So, before reaching this 563 Kelvin, they will decompose. So, we have to reduce its pressure to 12 mm. As a result of this, their boiling point also decreases to about 453 Kelvin. Okay. So, before reaching the boiling point, the original boiling point is 563. On reducing pressure, its boiling point decreases to 453 Kelvin. So, we can easily distill this compound. Okay. Now, this is one of the important use or the application of vacuum distillation or distillation under reduced pressure. That is, glycerol is used in the soap industry, which can be removed from the spent lye. One important application. Okay, glycerol can be removed from spent lye in the a component in the soap industry. So, okay, soap industry, glycerol is an important component in the soap industry. This can be removed from the spent lye using this method. Another application in sugar industry. It is used in the sugar industry. Okay, in the sugar industry, this is used to concentrate sugarcane juice. Okay, concentrate sugarcane juice. These are the important applications. Okay, now let us explain about the apparatus. Apparatus consists of apparatus. Round bottom flask in which we are taking the mixture, round bottom flask. Okay. Now, next there is a condenser which condenses the liquid. Condenser is there. Okay. There is a vacuum pump is used in this case, because by using this vacuum pump we can reduce the pressure. Okay. In order to reduce the pressure, we are using a vacuum pump. Okay. Now next is receiver, where we are receiving the liquid, the condensed liquid. Okay.